understand SQL data. Last time we understand the SQL table, the fundamental concept, SQL table. We will later, do more understanding on SQL tables. So today, another fundamental concept in SQL, the data, understand the structure, properties of SQL data. B.1, numeric and string data. Two most important data types in SQL. So let's look at the properties, numeric and string data properties. All right. First, let's look at the numeric data type. There are several numeric data types. The first one, integer data type. And first, you need to declare your field. Usually, when you define a particular field or column or attribute, sometimes you need to use the integer data type. So the integer data type, various size. One way you type the whole integer word, another just int. The same. Same thing. int. And if you use lowercase, it's quite common. People also use the lowercase. For the data type. All right. And inside the parenthesis, number of digits. How do you specify the size, right? So inside parenthesis, number of digits for your integer. Here, 2 digits. Okay? So usually you look at how do you use your data. Because sometimes you need larger data sizes. So you need to give enough number of digits. But sometimes you don't need that large number of digits. So you don't want to waste, storage space. So you will use smaller number of digits. All right. Default 0. So if the value is not provided, we take the 0 value as its default value. Later we will talk about this default again. So we have other places we talk about default. And another thing, I hope you still remember, I mentioned before, this backtick, right? It's not single quotes, backtick. That symbol we use to avoid keyword conflict. Remember, keyword conflict. SQL keyword. If you use the SQL keyword, SQL keywords, if you use SQL keywords as your table fields or table names, you would get keyword conflict. That's the syntax error. Okay? So DBMS would complain and reject. So reject your, table definition. And you don't want that happen, right? So one way people may change the names, use a different table names or table field names, but sometimes the table names and field names are determined by your business. You cannot change different names. Your business has to use particular names. Yeah, I had that experience before. All right. Yeah. So when I changed to a different name, so then the business, the company, they complain. So you cannot make the change. But that business name could be the same as the keyword. How do you avoid it then? The back tick symbol, then the DBMS would interpret it as non-keyword string. Yeah, non-keyword string. So no problem. Yeah, all right. I had an experience before in MySQL. Yeah, still in MySQL. When I use MySQL has a keyword called use. Use is keyword in MySQL. When do we use this keyword? When we select a database, we use this command. Use database name, your type, okay, in your SQL command window, because you have large number of databases. How do you select one particular database? Yeah. In our PHP MyAdmin, we click the database link, we make the selection. But there is another way. Sometimes people use the command line. Okay? Sometimes people may need to type commands at a command line. At the command line, they type use database name. Yeah. The command is use your database name. Okay? Yeah. When you type this, you run this command, that particular database is selected as the current database. Okay? Yeah. If it's current database, when you run all the SQL commands or the SQL queries are based on the current database. Yeah. Otherwise, yeah, there is another way people type commands. If you do not specify the current database, when you type SQL commands, when you need to refer to a table, you need to type your database name dot table name. Okay? All right. So if you do not select current database, if you do not select the current database. Okay? Yeah. That means you do not click the link in the GUI tool managing your databases, or you do not type use the database name, then no database is selected as the current database. Now, how do you run the query? Okay? So here, when you run the query, when you refer to the table, you need to type, yeah, so here, in your queries, okay, when you refer, so here I just skip the command part. When you need to type the table name, type database name first, okay, all right, DB name dot, all right. Yeah, otherwise, which database you are working on? Because you do not tell the DBMS which database you are working on, right? So you need to type the DB name dot, then table name, okay? Table name. Yeah. Dot, 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 all right? Yeah, because in that way, all your queries you need to do this way. DB name dot table name. All your queries you need to do this way, okay? But if you select current database name, then you can skip the database name dot, that part, okay? Only type table name, because DBMS knows the current database you are using. Yeah. So that's the the thing. Because when I do the grading of your query statements, many students, they give me the DB name dot. Yeah. Because for us, we always select the current database. Yeah. So we skip the DB name. Yeah. But some students, yeah, because they search the commands from the web. Yeah. So many commands from the web, they include that DB name part. Okay? Yeah. Include that DB name part. Yeah. So here I just tell you the difference. Yeah. All right. Yeah. So that's some basic information. Second numeric type, floating point, real numbers of various precision. Float or real, that's the single precision. Yeah. Another type, double precision. We need to use double. Okay? All right. Yeah. Formatted numbers can be declared by using, yeah, because sometimes when you declare, non-integer numerical values, single, double precision, you want to specify the precision information. Yeah. Here, this way, so so here, three ways you can use. One is the decimal with two parameters, ij parameters, for different meanings, or dec ij, numeric ij. Yeah. Here, let me give you the meaning of ij. First, I. So what's the meaning of I? Yeah. So in our textbook, it tells precision I, the total number of decimal digits. Yeah, this part is correct. Yeah. But for this precision, this name, a little confusing. Yeah, a little confusing. Yeah, because when people use the scientific notation, the precision part refers to the number of digits after the decimal point. Yeah. But here you see precision here, it contains all the digits before and after, then it may cause some confusion. So you need to be aware of that difference. Yeah. Actually, this part, because that's the total number of decimal digits. So when people use the scientific notation, people call it effective digits. Effective. Yeah. Effective number of digits. Yeah. In that way, you try to avoid using that precision name, because precision name we use after. Yeah. So here the scale. In scientific notation, people say precision, the number of digits after decimal point. The scale, this part. Okay? Yeah. So here, the reason is because in different context, the meaning of the same word could be different. Meaning of the same word could be different. Yeah. Yeah. Just be careful. Okay. Yeah. Yeah. Otherwise, people get confused. Okay. Yeah. All right. Yeah. But I and j, I total number of digits before, after decimal point, so include the j part. Yeah. So by this definition, I always greater or equal to j. Yeah. Yeah. Because you may have certain number of digits before the decimal point. If no, then the same. I and j the same. Yeah. If there is no digit before decimal point, okay? Yeah. Yeah. Then I and j the same. Yeah. All right. Yeah. For example, here, let me give you an example. When we declare float, float, you may like to use this way also. Yeah. So it's very common when people declare float data type 4, 2. What's the meaning of your float data type? Yeah. Total digits up to 4. You can use fewer than 4, okay? Up to 4. Yeah. The maximum number of digits before decimal point, after decimal point, it's 4. But after decimal point, you can use up to 2 digits. Yeah. Up to 2 digits. Yeah. So that's the meaning. Yeah. For non-integer numerical values, you can use this way to provide information before, after decimal point. Yeah. All right, so that's the numerical values. Yeah. All right. But for numerical value, you need to be aware approximation. Yeah. Approximation issue. Yeah. Because some numbers cannot be represented in an accurate way. Yeah. Approximation. Yeah. So this small approximation error, there is an error, truncation error. Yeah. Because if the computer cannot represent specific numerical number precisely, it will do truncation. When it does truncation, there is small error caused. Yeah. So here, I may like to point that out a little bit. Yeah. So errors, truncation error. So here, let me talk about truncation errors. Yeah. For non-integer. Because if you use integer data, there is no truncation error. Okay? They're always exact values. Yeah, no error. But you use floating point, double type, yeah, so you may have the truncation errors. Okay? For non-integer numeric values. Yeah. Then you need to be aware of this. Yeah. Although this type of error is usually very small, yeah, because in computer very small, but you need to be aware that small errors could be accumulated, right? Small errors could be accumulated and become larger and larger. All right? Yeah. So here, let me give you a simple example. Yeah. Truncation errors. Okay. All right. Because inside computer, we know computer use the binary system, right? Yeah. Computer use the binary system. The numerical value in binary system. Okay? We know every decimal number can be converted to binary system easily, right? Yeah. But the question is, when you convert decimal representation after the decimal point to the binary, okay? So the decimal point, yeah? Not before. Before integer conversion, then no problem, yeah, because no error, right? But after decimal point, after the decimal point, then if you convert it to the binary fractional numbers, then you will get truncation errors. You may get truncation errors. Yeah. Why? So let me explain. So that would cause errors. All right. Let me use this space to explain. Example. All right, examples. Yeah. Think about decimal, yeah, so here, for decimal 0.5, decimal, okay? when you convert to binary, what would you get? 0.5, 1/2. Okay? 1/2 to binary, is it 0.1? Right? 0.1. Binary. Okay? Yeah. All right. Decimal, 0.25, 1/4. 1/4. Okay? When you convert it to the binary, 0.01. Okay? Yeah. All right. Now, I ask you, the decimal 0.3 decimal to binary, what would you get? 0.3. Okay? So simple. So simple. 0.3, it equals 3/10. 3/10. Okay? If you convert to the binary representation, you need infinite many bits after the binary point. Infinite, yeah. Because here you can see the denominator is a 10. 10 is not a power of 2. Power of 2. If the denominator is not a power of 2, then you have to have truncation errors. Okay? You cannot represent in the binary representation precisely. Okay? If you use the binary representation, then you cannot represent in a very precise. You have to lose some precisions. Yeah. In that way, yeah, you should be careful, yeah, because in some applications, for example, in banking industries, yeah, so you need to use the non-integer numerical values to represent the money amount, right? Then, in your representation, you may have truncation, small truncation errors, very small. Yeah. But we know banking industry, each bank, they may process large amount of money. So if that small amount accumulated, that could be relatively a big number caused by the system. Yeah. Internal numerical representation system. Okay? That potential problem. Yeah. All right, yeah. Just let you know the special properties of the numerical values. Yeah. Next, character string data type. Yeah. The second basic type. Yeah. Fixed length and a variable length. Yeah. Fixed length. Yeah. So when you use the character, CHAR or character, so most of the time people use the shorter way. Yeah. And with number of characters specified, it's a fixed length. So this one, fixed length. Yeah. Fixed length, that means each field takes this many characters, it's fixed. Yeah. But sometimes you may not use all of these characters. Sometimes you may just use some of the characters. Yeah. So then, in that situation, yeah, because fixed length, in that situation, you need to pack it by space characters. Space characters. Yeah. You need to fill it up. Fill up that number of characters you declared. Yeah? Yeah. All right? Yeah. So that's the fixed length. Varying length, then you do not need to fix. Yeah. So usually people like this way. People use the variable length more. Yeah. Because you have more flexibility. you only need to use up to this number, okay? You have to fill it up to this number. Yeah. Because some of your data field, you may need to use thousands of characters. Yeah. For example, you want to store an article. You want to store an article. How many characters do you want to allocate to that field? Right? So, because if you do not allocate enough number of characters, when you store an article longer than that number, it will be truncated. Okay? For example, you only allocate 5,000 characters, but there is article has 10,000. Then after 5,000, all the remaining string part all truncated. Okay? Yeah, so you need to be aware of that. So that's why for that kind of application, you want to allocate enough many characters for the data you want to store. Otherwise, truncated. Okay? Yeah. So you need to be aware of that. Okay? All right. Yeah. But this varying length, if you do not use that many, right? Yeah. The good thing about this is if you do not use that many, because sometimes you put a relatively large number, let's say 3,000 characters. But for that particular row, the data only has 10 characters. Okay? 3,000 the maximum, but you use only 10 characters. Don't worry. Yeah, don't worry. Yeah, because it's a varying size data. You do not use the large part, then the DBMS won't waste that part. Okay, the DBMS would find a way only use the part that you need. Okay, only use the part that you need. Yeah, so the remaining part not wasted. Yeah, so that's the good thing for this type. var char this type. Yeah, varying size. Yeah, type. Yeah, all right. So here the content takes 3,000 characters. Yeah. But if your content does not use that many, so don't worry. Yeah, so that space won't be wasted. Yeah, the space will be saved, so the DBMS would find a way to save that space. Yeah, yeah, yeah. All right. Yeah. Okay. Yeah, and yeah. Before I move to the next topic, because for the fixed length, yeah, there is one thing. You have to occupy that many characters. Yeah, because it's fixed length. Yeah, fixed length. For example, if we declare char, let's say 8 characters. Yeah. But your particular field, you only have 3 characters. Yeah. You do not need to use all the 8 characters. Yeah. Then, first store your 3 characters. After that, use the space character to fill it up. And so the first space character, second, third, 5 space characters, pack it after your 3 characters to get total 8 characters. Yeah, pack it at the right, not left. At the right, not the left. Okay? Yeah? Yeah. yeah, not left, not, yeah, at the right, not left. Yeah. Why? Yeah, the reason is very simple. Yeah, the reason is very simple. Because later we will look at the comparison. Yeah? Because when you store your data, you want to do the data comparison. When you do data comparison, you start first comparison from leftmost position. Then, second, and so on. You use the dictionary order. Dictionary. How do you find a word in a dictionary, right? You look at the leftmost character. Then, second, third. So, yeah. So you use the dictionary order. To do the comparison. Okay? So later we will talk about this question again. Yeah. Here, just let you know, because the leftmost character is the most significant character in your data. So you should not pack the space characters at the left. Otherwise, you will change the leftmost character, right? You don't want to change your leftmost, most significant character. So for that reason, you pack them at the right. Okay? Yeah. All right. Yeah. So that's this data type. Yeah. Next, B.2, understand null value. This null value is very important in SQL. Special, but it has many very special properties. So we will spend quite some time to study the null value. Yeah. In our programming language, we learned the null object, right? Null object. Yeah. C++, Java, we all have the null object. Yeah. Yeah. So you have that concept. You know it's a special object. Okay? Yeah. Null object. Yeah. So there is no content in that object. Okay? Yeah. Yeah. All right. But in SQL, it has a lot of special meaning and properties. Yeah. So we will really need to understand this null value. Yeah. All right. So let's look at that. So what is the null value? What's the meaning? So why people created this special value in SQL? Well, because in business, there are several situations you may need to use a very special value to give people attention. Yeah. You have to do something. Yeah. There is some special question. Yeah. You need to find a solution later. Yeah. Because at current time, you may not know how to solve it. You can delay a little bit, but you need to be aware the problem there. Okay? Yeah. So let's look at the details regarding the special value. Null. Null is used to represent a missing value, yeah. but it usually has one of the three different interpretations. Yeah. Yeah. This value, first, it's not available. Yeah. We know that. Yeah. Yeah. If it is available, you won't use null. Yeah. So the reason you want to use the null, it's not available. Yeah. So you want to put a mark. Yeah. You want to put a special sign, symbol there, yeah, to make people to put a warning sign. It's like a warning sign, alert. Okay? Alert. There is a problem. You need to fix it. Yeah. 3 different interpretations. The first one, unknown value. Unknown. Exists, but not known. Yeah. When people enter, let's think about people, a company enter a new employee's information. Yeah. A new employee comes to a company. Yeah. First, you need to get an account, right? Yeah, create an account. But when you create an account for that employee, you may not have all the information of the employee, right? Like birthday, some special information. You may, you need to contact that new employee, but when people do the data entry, so they need to put something there, right? So it's not available, but yeah. So here, one good way is put this null value. Yeah. Because when you put a null value, when you do the queries, you get something different. Yeah. Because it's not a normal value. Yeah. If you put other normal value, for example, because sometimes people put a normal value, if the value is not known, people may put a empty string, for example, empty string value. That's another commonly used way. But the empty string value, the problem is no warning. Yeah, because normal value, then no warning sign. Yeah. It is treated as a normal value, so you won't send people alert, right? Yeah. So in that way, so it's hard to fix. Yeah. People may forget. Yeah. People may forget to fix the problem here, right? So for that reason, you like to put a special null value. Okay? Yeah. So people always see the null value, then they have to fix it. Okay? All right. So that's the first case. Second case, unavailable or withheld value exists but is purposely withheld. Yeah, that's another situation. Purposely withheld. Yeah. Yeah, because some value that could be, sensitive, for example, very sensitive, people just don't want to put there. Okay, withheld. Yeah. Yeah. So, yeah, try to protect the data, yeah, for that particular reason. Yeah, putting another higher level security level protection for that piece of data. Okay, yeah. In that situation, so you just imagine in the business requirements. Yeah, that case you can also put a null. Yeah, so people will be aware when you get here, you need to ask some questions. Yeah. So what's wrong with it? Yeah. What's the problem here? Yeah. That's the second type. The third type, not applicable attribute. Yeah. Yeah. Sometimes, some data field, does not make sense, right? Not applicable. Yeah. For some people, it's not applicable. Yeah. That happens frequently. Yeah. Yeah. So then you can also choose null value. Okay? Yeah. Because let people know, yeah, this place, you should not handle the values like the normal values. Yeah. Because you have option to replace it by a normal value, then people may handle it in the wrong way, right? By the normal value. It's a wrong way. Yeah. So you just try to let people aware of it. Yeah. Do not use the normal way to handle the values. Yeah. All right. Yeah. So typically, these three different interpretations, but it's usually, so definitely you have other interpretations other than these three. Yeah. Three just give you, relatively more common cases. Yeah. Definitely you can have other special cases. Yeah. So you need to put the null value. All right. Yeah. So that's the first property, meaning. Yeah. Why use null instead of some special value? Yeah. So I already explained a little bit. If you use some special value other than null, because these special values are treated as normal values. Okay? So they are normal values. Normal values, then people won't get alert. Yeah. Everything is normal. Okay? People won't get alert. Yeah. Yeah. But actually, there is something special here. Not quite normal. Not quite normal. So you want people to fix the problem as soon as possible. If you put normal values there, people may never fix the problem. So that's the, main difference. Yeah. All right. Make users aware of it. Yeah. Then you can fix it. Yeah. So you can, just keep sending warning signals to the users to fix every time they see this irregular value. Yeah, they need to, try their best to fix it. Yeah. All right. The DBMS treats it differently from other values. So when you do the queries for this particular value, you get a special result. Yeah. Different, separated from the normal query result. Yeah. So then, something not quite right could occur. Yeah. So at least someone needs to solve the problem. Yeah. All right. Handling null values in DBMS. Who determines the meaning of null? Yeah. So many different meanings. Who determines the meaning of null? Not a SQL. SQL cannot determine. Okay? SQL just treat it as null using the internal SQL way to process the null. But it does not know what's the exact meaning of it. Yeah. Yeah. SQL does not distinguish among the different meaning of null because SQL does not know the business, right? Yeah. The meaning is closely related to your business. Yeah. Yeah. Only people who are familiar with the business details, they can separate different meanings of the null. Yeah. All right. Not DBMS. DBMS cannot, because DBMS does not know your business details. So DBMS cannot separate the specific meanings. Yeah. People who are familiar with the business rules, they can explain. So what's the exact meaning of the null there? Yeah. All right. Yeah. Different individual null values. Yes. So here, another property. So this is another property. So what's the meaning of different individual null values? Yeah, here. Because sooner or later, you need to compare two values. You need to compare two values. They happen to be both null. How about that? Okay? Yeah. So so let's assume you do this. Yeah. You do this. Okay? All right. You compare yeah, row 1 dot field 1 with row 2 dot field 1. Okay, you do that comparison, all right? But they happen to be both null. Yeah, they happen to be both null. Okay, that's possible. Yeah. Here, this property tells us DBMS treat this case two different values. Yeah. Row 1 dot field 1 and the row 2 dot field 1, although they both have the null value, but DBMS treat them as two different values. Okay, that property. Yeah. Why? Let me explain. Yeah. All right. Row 1 dot field 1, it's null, so the value is unknown. Later, a new value will be put there. Okay? A new value will be put there. All right. Row 2 dot field, although currently it's null, later another value will be assigned to that place. After they get their correct values later, it's very likely those values are different. So for that understanding, so DBMS treat them as different values. Yeah? Because very likely, in general, they are different. Only in some very special case, they could be the same. Yeah. But in general, they are different. Yeah. So that's the reason DBMS treat them as different individual null values. Although they appear the same look, null, because null value is special. Okay? So DBMS treat them as two different values. Yeah. Be careful on that. Yeah. Each individual null value is considered to be different from every other null value by DBMS. Yeah. The reason, yeah, because later when you put the right values there, very likely they are different. In general, they are different. Yeah. All right. The comparison logic is different. So then when you do comparison, the result would be different. Yeah, later we will talk about the result. Okay? Yeah. So we will separate. We use special ways to handle the result, comparison results. Yeah. All right. Yeah. So the way, yeah. So if, yeah, because you need to use special property. Yeah. When you need to check if a field takes the null value, you should use the is operator. You should not use the equal operator. Yeah. If you equal operator, you always get false because they're different. Yeah. Don't use the equal operator. Equal operator, when you compare with another null, you always get a false because they are treated as different. So you should use the is, special is operator, then you get a true. Yeah. Yeah. So, for example, the is, that means, so if you do comparison, let's say row 1 dot field 1, this time is null, okay? Yeah. You do not know equal null. Is null. Yeah. If it is null value, then it is true. Okay? So you take it. Yeah. The DBMS returns the true value. So it is selected. Yeah. Yeah. If you use equal, if you do not use is, use equal, you get a false. Okay? Yeah. So if you use equal here, the DBMS will return false. Boolean value, it's false. It's not true. Okay? Yeah. That difference. Yeah. All right. Yeah. Yeah. So remember, this is operator. Yeah. All right. B.3, other data types. Yeah. So there are a few other data types that could be useful. Yeah. All right. So here, yeah. Let's look at the Boolean data type. Boolean. Yeah. We know, very useful. Yeah. But in SQL, regarding the Boolean data type, it's a 3-valued logic, not a 2-value logic we use in our programming language. Programming language, when we use the Boolean data type, we only use true and false, only 2 values. But in SQL, other than true and false, there is an unknown Boolean value. Why unknown? Because null is involved. The null value is involved. Which one you should use? If you use true, not 100% correct. If you use false, not 100% correct. Yeah. Yeah. Sometimes it's true, sometimes it's false. Yeah. Because when you compare the null value, later its real value is provided, then it could be true, it could be false. So for that reason, you use unknown. Unknown, the third Boolean value in SQL. That's quite special. Yeah. So you need to prepare yourself mentally for this important difference, SQL value difference. Yeah. So that's the Boolean data type. Then the data data type. So this is the data data type. Yeah. Data data type, so you use the standard way. This is the standard. We know SQL, it's a standard, international standard. Okay? People from all countries in the world, they have to use the same standard, SQL standard. Okay? Yeah. Yeah. We know for the date representation, different countries, they use different special date representations. Yeah. But when you use SQL, all the countries, all the people use SQLs, you have to first 4-digit year number. Okay? Dash, yeah, not other symbol, only dash. Then 2 month digit. Dash 2 day digits. Yeah. All right? Yeah, 2 day digits. Yeah. All right. But there is some little thing, yeah, because we know some of the months you do not have 2 digits, you use 0, right? Yeah. Like 2024, for example, yeah, today, February, use 02, right? Yeah. Yeah. Then 21, today, okay? 01, yeah. You use 0. Yeah. For some of the day number, you may use 0. 05, for example. Okay? Yeah. But, although we say this is the standard format, yeah, but if you use a single digit, for example, 2024-2, only 2, yeah, you skip that 0. It's still correct. It's not wrong. Okay? Yeah. So the DBMS will insert that 0 for you. Okay? Yeah. You as a user, when you enter data, you skip that 0, the DBMS still takes it. It does not reject it. Okay? Yeah. Because it's a small problem, so DBMS does not reject it. Okay? But when you look at the data entered in the table, you will see that 0. Okay? You will see that 0. Yeah. Yeah. Similarly, for the date number, if you just enter single digit number, DBMS accepts it. Yeah. Yeah. But what do you see? 0. The standard format. 0 is added to make 2-digit representation. Yeah. All right. Then for the time data type, so you use the standard way. Yeah. All right. But there is another one called daytime data type. Yeah. Because sometimes people represent the current time, including the date part. Yeah. So it's called a daytime data type. Okay. So you write together. Yeah. So date, time, data type. Okay? Then you add these two. Yeah. So Y, M, D, but you need to put a space. Yeah. Space after it. Then H, M, S. Okay? Yeah? Yeah. So that's called a daytime. Yeah. The data type. Yeah. Yeah. So put them together. All right. Yeah. Like that. Yeah. All right. Yeah. About 5 minutes. Yeah. Let's look at B.4. Compare values. Yeah. Let's look at one slide in part of B4. Yeah. All right. Compare values, general, we use equal sign for comparison. Yeah. For exact match, yeah. Equal operator. Yeah. No order for comparison field is required. When you use equal sign, then DBMS does not need order information. Order. Usually the data has the order information. Yeah. But in some very rare cases, it does not have the order information. But for the equal sign, no order information is needed. Yeah. All right. Without order definition for the field, it still works. Yeah. But we know 90-something% of the time, there is order definition. Yeah. But very small or special cases, yeah, order definition may not be available. Yeah. All right. Then less than, greater than comparison operators, then you need order information. Order must be defined. Then you can use these two operators. Yeah. Otherwise, you cannot make comparison. Yeah. All right. Or order must be defined. Yeah. And order must be defined. Yeah. All right. So that's the basic value comparison. Okay. Compare values for individual data types. Yeah. All right. Still, yeah. Let's do another slide. Numerical data types. We use natural value order. Numerical, the order defined. Okay. So we do not need to worry about it. Yeah. We can always compare two values. Yeah. So natural value order. But for string character data type, then you need to use the alphabetic order. People also call the people also call the dictionary order. Okay? Alphabetic order and a dictionary order. Yeah. All right. So when a string value happens to be a number, do not get confused with these two orders. Yeah, because sometimes a string value could be, digit, only digit characters. Yeah. Then you should not use the natural numerical order. Yeah. All right. Yeah. So here, let me give you the example. All right. For example, you have 1, 2, 3 digit. Okay. This is a string. So I use single quotes around it. This is a string. But there is another one, 5, 4. Only 2 characters. But when you do string comparison, 5, 4 is greater than 1, 2, 3. Because use the alphabetic order, 5 is greater than 1. So you already determined the order using the first character. Yeah. So you do not use the numerical value 54 and 122. So do not get confused for this part. Okay? Yeah. All right. So that's it. Let's stop here. Next time we will finish remaining slides quickly. Yeah. All right. That's it.